Pulse Talk, bringing insights into health and wellness with your hosts, Christine and Alex.
Okay, imagine this scenario. Maybe you've heard something like it. Someone you know starts a really common medication for cholesterol. Something supposed to help their heart.
Mm. Happens all the time.
Right. But instead of feeling better, they suddenly get these really bad muscle aches. Makes climbing stairs, even just walking around, kind of miserable.
Yeah, that can definitely happen.
It's a bit of a puzzle, isn't it? Why would a medicine, designed to help cause that kind of discomfort? And crucially, why isn't it the same for everyone?
That's the million-dollar question.
So today we're doing a deep dive into statins. Specifically, atorvastatin comes up a lot. It's one of the most prescribed drugs globally.
Absolutely huge.
And these meds are, well, they're powerhouses for lowering that bad LDL cholesterol. For the vast majority, they work incredibly well. Minimal side effects, if any.
They really are lifesavers for millions. Reduce risk of heart attacks, strokes, significantly.
Exactly. But, and here's the twist, for a smaller group, the story is just completely different.
Right. That's where the problems can start.
These folks experience significant muscle pain, sometimes weakness, or even though it's rare, a more serious thing called statin-induced myopathy.
Myopathy. That's one we watch out for.
So the central mystery we want to unravel is why? Why do some people react so badly to these generally beneficial drugs while most sail through? What's going on under the hood? Okay, let's unpack this.
You've really nailed the core issue.
Yeah.
Statins, they've undeniably changed the game for cardiovascular health. Their success in lowering LDL is, well, it's rock solid.
Totally. A cornerstone, you could say.
Definitely. And for most patients, the benefits, they just massively outweigh any mild side effects they might feel.
Right. But it's that stark difference for the minority where muscle issues become a real, quality of life problem. That's what makes you ask questions. So what exactly are we talking about with these muscle side effects for that group?
Well, for that small percentage, it can range quite a bit. Sometimes it's a general muscle pain or tenderness, what doctors call myalgia.
Myalgia, okay.
Other times, it's actual muscle weakness. And it's important to stress that this isn't just, feeling stiff after a workout.
No, it's different.
It's persistent, sometimes really debilitating. An ache or weakness that isn't tied to doing anything strenuous. And in the more severe, thankfully rarer cases, you get statin-induced myopathy.
And that means actual muscle damage.
Exactly. It indicates real muscle injury. And we can often detect that objectively by measuring certain enzymes in the blood, like creatine kinase or CK.
CK levels, got it. So for some people, it's definitely not minor. It can really impact their lives. Which brings us back to the why. If the drug's the same, what explains this variation? What's the sort of hidden factor?
Okay, this is where it gets really interesting. The answer very often lies in our genes, our genetics.
Ah, genetics, okay.
Research has really zeroed in on one specific gene. It's called SLCO1B1. SLCO1B1. And it's a key player in how our bodies handle statins.
SLCO1B1. So how does that work?
So think of it like this. Your body has this complex transport system for medications, right? The SLCO1B1 gene gives the instructions for building a protein.
A protein?
Yeah, and this protein acts like a gatekeeper or a pump, almost like a specific toll booth on a highway, just for statins.
A toll booth for statins. I like that.
Its job is to grab the statin from your bloodstream and transport it into your liver, because the liver is where the statin does most of its work, lowering cholesterol production.
Okay, so the liver is the destination.
Right. Once the statin cars get through that SLCO1B1 toll booth into the liver, they do their job, and then the liver clears them out of the body. It's a vital step. Get in, work, get out.
So the statin is the car. SLCO1B1 builds the entrance ramp in the highway lane into the liver where it works and then exits. That clicks.
Exactly. Perfect analogy. For most people, their SLCO1B1 gene works great. It builds a wide, clear, multi-lane entrance ramp. Smooth sailing. The statin cars drive right into the liver, no problem. They do their job efficiently, get cleared out. That's why statins are so effective for so many people.
Okay, but what about the people who do have problems?
Okay. So here's the crucial bit. Some people have a certain variant of that SLCO1B1 gene, a slightly different version.
The genetic variation.
Precisely. And if you have this variant, it's like that multi-lane highway entrance suddenly narrows down to just one lane. Or maybe there's construction, it's partially blocked.
So instead of smooth flow, a traffic jam. The cars can't get off the bloodstream highway fast enough.
You got it. A traffic jam in the bloodstream. The statin cars can't get into the liver efficiently. They back up. They pile up in the blood.
Okay.
So now you have a higher concentration of the statin just circulating around your body for longer than it should be.
And that's what causes the muscle problems.
That significantly increases the risk. Higher levels in the blood, outside the liver, are linked to that muscle damage. And this can happen even if you're taking a totally standard dose.
Wow. So the same dose can be fine for one person but problematic for another just because of this gene difference.
Exactly. It's fundamentally about how your specific body handles the drug based on your genetics. It's not that the drug itself is inherently bad.
That's actually pretty profound. It's not a bad drug. It might just be a bad fit for your particular genetic makeup. Okay. So what does this all mean for, you listening? Or maybe someone you know who's taking statins or might need to? What are the practical takeaways here?
Yeah, good question. And this really raises an important point about, well, personalizing medicine. The main thing is this. If you or someone you know starts a statin and you begin to notice that persistent muscle soreness or pain or weakness.
Stuff that's not just workout stiffness.
Right. Anything that feels unusual and doesn't go away, it is absolutely crucial to talk to your doctor about it. Don't just ignore it or try to tough it out.
And definitely don't just stop taking the medication on your own.
Absolutely not. Stopping abruptly can have serious risks for your heart health. Always talk to the doctor first. They have options.
Okay, so what can the doctor do?
Well, they have a kind of playbook. First, they might just try lowering the dose. Often, a lower dose still gives good cholesterol-lowering benefits, but might ease up on the muscle side effects.
Makes sense. Less drug, maybe less buildup.
Exactly. Another common step is switching to a different type of statin. There are several kinds, and they aren't all processed exactly the same way by the body. One might just agree with you better than another.
Try a different route, basically.
Sort of, yeah. And they'll likely want to check your blood levels of that muscle enzyme we mentioned, the CK, creatine kinase.
To see if there's actual muscle damage happening.
Correct. Elevated CK gives them objective evidence to help guide the decision. Is it just discomfort, or is there underlying injury?
Okay. Lower dose, different statin, check CK levels.
Got it. Yeah. And Tomoke, looking a bit more to the future, or even now in some places, this is where we touch on that cutting-edge field, pharmacogenomics.
Pharmacogenomics, okay.
Basically using your genes to predict drug response. In some more advanced healthcare settings, they can actually do genetic testing before you even start the statin.
Really? Before symptoms?
Yeah. By checking your specific SLCO1B1 gene variant, for instance, doctors might get a clue about your potential risk for muscle problems before prescribing.
Wow.
This could allow them to maybe choose a different statin from the get-go or start you on a lower dose right away.
Yeah.
It's about using your unique genetic blueprint to make treatment more precise, more personalized, minimizing that trial and error.
That's incredible, avoiding the problem before it even starts.
If we connect this to the bigger picture, it's clear statins are vital, often life-saving. But like pretty much all medicines, they are definitely not one size fits all.
Right.
Understanding your personal response, potentially even down to your genetics, can really be the key to getting the heart health benefits without those unnecessary and uncomfortable side effects.
It's a really powerful thought, isn't it? This whole idea of personalized medicine, that genetic insights could guide treatment before you even feel a single symptom.
It's the direction things are moving.
Imagine your doctor having a much better idea of how you specifically will react before you even take that first pill. It really underlines the value of being proactive, getting treatments tailored just for you, leveraging science in a way that's designed for the individual.
More targeted, less guesswork.
Absolutely. And speaking of fascinating insights into personalized medicine and how drugs work differently in different people, in our next deep dive, we're going to explore why some blood thinners don't actually thin the blood properly for certain individuals.
That's a big one.
Yeah, and how that can be a hidden danger, especially after things like heart procedures. So definitely stay tuned for that.